In this video, we will introduce the concepts of stationarity and cyclostationarity for random processes. We will start with intuitive definitions. A random process is stationary when the statistics doesn't change with time, they are constant. And a random process is cyclostationary when the statistics are changing with time, but they are repeated periodically. So we have cyclic statistics. These are the intuitive definitions. Now we'll formalize mathematically these intuitive concepts. We will start with the strict sense definition of stationarity. And this definition is made in terms of the statistical description of a random process, in terms of probability density functions. And a random process is a strict sense stationary when for every set of n time instants and for every value of n, the joint PDF of the n random variables that we have when we evaluate the random process in the n time instants doesn't change with time. If we increase all the instants a given value delta, the PDF remains constant. The PDF depends only on the relative distance between the time instants, not on the time instants themselves. This is the strict sense definition of stationarity. In some cases, there is a definition for a given order m, and in this case, the number of time instants is limited to be at most m, the order of this strict sense definition of stationarity. This definition is really strict, and in some applications it's difficult to use this definition, and it's necessary to use a more relaxed definition of stationarity, as it happens, for instance, in the analysis of communication systems. And because of this, we have the wide sense definition of stationarity. And a random process is wide sense stationary when two conditions are satisfied. The first one is on the mean. The mean of the random process is constant, doesn't depend on the time. And then the second condition is for the autocorrelation function. The autocorrelation function in two instants t1 and t2 will not depend on the specific values on t1 of t1 and t2, but only on their difference, only on their separation. And this separation usually is defined as tau in the literature. Because of this, in some cases, the two time instants are parameterized as two instants with a given separation. T plus tau and t are two instants with a separation equal to tau. And in this case, the autocorrelation will depend only on this separation, on tau, and will not depend on t. This is the wide sense definition of stationarity. Similarly, we have a wide sense definition for cyclostationarity. Again, with two conditions, one for the mean, another one for the autocorrelation function. In this case, the mean now depends on time, but this dependence is cyclic, is periodic, with a given period t0. And the same thing happens for the autocorrelation function. The autocorrelation for two instants separated tau will not depend only on tau, will depend also on t, but the dependence on t is cyclic, with the same period t0. This is the definition of cyclostationarity. Both the mean and the autocorrelation function will depend on time, but periodically. Here we have an example of a stationary random process, wide sense stationary. In this case, the mean of the process is constant, 1/2, and the autocorrelation function for two time instants t1 and t2 depends on the difference between t1 and t2. We have a cosine of omega 0 times t1 minus t2. If we parameterize the two instants as two instants with a separation tau, the result, the autocorrelation, depends only on tau and will not depend on t. And we have here another example, in this case for a cyclostationary random process. In this case, the mean depends on time, but this dependence is cyclic, is periodic, because it is inside of a cosine. And the same thing happens for the autocorrelation function. For two instants T1 and T2, the first term that we have here, this cosine, depends on the difference between T1 and T2, but this term here has a dependence that is depending on the addition of these time instants. If we parameterize the two instants as two instants with a separation tau, this term depends on tau, but this term depends too on the time. We have a dependence here for the autocorrelation with the time. We have a dependence here for the mean with the time, but this dependence is inside of a cosine. We have a cyclic, a periodic dependence. And here we have a picture with a plot of the mean and the autocorrelation function. For the first example, the stationary random process, we can see that the mean is constant and then the autocorrelation is depending only on the difference, on the separation between time instants. And this is the mean for the second example. In this case, we have a cyclic and periodic mean. And the same thing happens for the autocorrelation. For the autocorrelation, we can make different plots. In this case, we have a plot as a function of the separation between time instants, tau, and in the first example, for the stationary random process, we have the same variation with respect to tau for every possible value of t. However, in the second example, for different values of t, we have different evolutions of the autocorrelation function as a function of tau, as a function of the separation. However, this dependence is cyclic, is repeated with a given period. We have seen an example of a stationary random process and another one of a cyclostationary random process. But we can have also processes that are not stationary and they are not neither cyclostationary. For instance, this is an example of a random process associated to the random experiment of rolling a die. And in this case, we have 6 signals. One signal associated to each possible outcome of the random experiment. One of the signal is constant, 1/4, another one is constant, -1/4. We have a step at 2, we have a linear decreasing function, we have an exponential, and we have a sine, a sinusoidal function. Here in this picture, we have plotted these 6 functions. The mean is plotted below, and we can see that the mean is not constant and is not periodic. Therefore, this random process is not stationary, this random process is not cyclostationary.